As you browse through existing Node applications and libraries, you're likely to encounter a number of conventions that many projects use for one reason or another. Some of these are prescribed by Node itself, or NPM, while others have been developed in an ad hoc way. Others still are only one of many competing conventions you may encounter for the same topic or issue. In this section, we're going to go over a few of the most popular conventions in use today. This is by no means an exhaustive list, nor is it a prescriptive list. I'm by no means recommending the conventions we go over here. In fact, many of them, like package.json files or NPM, won't be in use at all during these lectures. Nevertheless, as you're likely to peruse many Node applications in the near future, I feel your Node.js education would be woefully incomplete if we didn't at least peruse the conventions that many developers use and have used to date. Let us start with the convention mentioned a moment ago, the package.json file. To illustrate this and the other conventions, we're going to return to the same sample application whose structure we reviewed in the previous lecture. Again, it currently consists of just a few files, an index.js and two separate library files within a lib directory. As an aside, this lib directory is a bit of a convention itself, though you may also frequently see a vendor directory or a node_modules directory, as we'll discuss in a moment. Dependency management. The package.json file, if this application had one, would live in this directory like this, just sitting in the root of the project. Inside, it contains metadata about the project, very similar to the data, such as this description, that we've already included in the index.js file. In our example, this includes the name, version, and description of the project, but many types of information may be included in the package.json file. We're not going to deep dive into this because this course isn't about NPM, but let's look briefly at one of the more important payloads many projects include in their package.json, a list of dependencies. If we add a list of dependencies to the package.json like so, and then run the npm install command, those projects are going to be installed inside of a directory called node_modules in the root of our directory. Let's say that, for example, I've gotten sick of our jokes, and so I've decided to find a third-party joke module on npm. I find the module called jokes, review its current version, and want to add it to my project. In that case, I add the name and version number to our package.json file here, and then run npm install on the command line. Now that project's code has been added inside of a subdirectory called node_modules, and I can require or import that library as I would any other Node module that I had written myself. But Node actually provides a helper for this. Since that module has now been installed in the directory called node modules, I can require it by just stating the name of the module. I don't need to write the relative or absolute path to the node modules folder. Node is automatically going to look for packages in that folder name by convention. After I run npm install, you'll notice I now have a package-lock.json file. This is the feature available on later versions of npm, which locks down the exact versions of the node modules you have installed. Since your package.json file may have specified your dependencies in such a way that they don't actually specify an exact version for each dependency, but lets the installer choose the newest from a range of possible dependency versions. Getting node modules installed into a node project is one of the primary purposes of npm, which is why it's named as such, the Node Package Manager. The package.json file is a primary artifact of npm and has a number of features and capabilities that we haven't gone into here. If a project has a package.json file, you may also notice a hidden file called .npmrc. This file is pretty simple inside and just contains a token that lets your local npm installation authenticate as a given user against the npm cloud. This enables npm to do things such as download private npm modules that the user has access to, but that an anonymous user would not have access to. As far as using these private and public dependencies, we've already gone over a few conventions in the last lecture. That you require or import modules generally at the top of a file, and that each Node.js file generally requires only the modules that it individually needs to perform its tasks, rather than some master file importing all the dependencies for a project and then passing those modules to other scripts. Testing and task running. Testing and task running are both quite popular in the Node community. Testing scripts are commonly contained in a /test directory and are often triggered or ran by a quote-unquote test runner, such as Mocha. If the project you're reviewing has a complex testing CI or deployment CD configuration and is using a CI/CD runner such as Travis CI, you may also notice a .travis.yaml file in the root directory as well, which tells Travis CI all the configuration that the project needs for the tests to pass, as well as other related settings. Similarly, if the project is using a JavaScript linter such as JSHint, you may see another hidden file, a .jshint.rc file, which configures the JavaScript linter in various ways. All of the kinds of tasks, JavaScript linting, test running, CI/CD operations, are often controlled by a general purpose task runner. The two most popular task runners are Grunt and Gulp. Accordingly, it's quite common to see Grunt files and Gulp files inside of Node.js projects. Documentation and source control. Git, and to a lesser extent GitHub, is by far the de facto source control implementation for Node. Git is the underlying protocol and application, while GitHub is a SaaS provider of cloud-based Git repositories, which facilitates easy collaboration among and between teams. As a result, you'll very commonly see a .git hidden file within Node.js applications and modules. You'll also see a .gitignore file, which, as its name implies, hides specified files and directories from source control. In addition, since GitHub has fantastic built-in support for Markdown formatting, you'll often find a readme.md file in the root of a project. This file, which should contain Markdown syntax, is automatically highlighted on the primary project page for a repository, so project descriptions and human-readable metadata about the project often goes in this file. The NPM Cloud, npmjs.org, has adopted this convention as well and automatically displays the parsed Markdown README for repositories, modules, on each package's homepage. Technically, there can be many different Markdown files in any given directory of a repository, as well as subdirectories. But in practice, you're likely to only encounter one readme.md file in the root of the project, and this file is likely to contain the vast majority of the documentation for the project. Documentation often also takes the form of code comments within JavaScript files, and a common convention is to use code comments above each function and the @param string to spell out a description of each parameter being passed to that function. This convention plays well and may very well have been born from the use of comment parsers that generate automatic documentation for projects. You're likely to encounter other code comments of various formats in many places within a Node app. Some developers opt to use the @todo line to indicate a feature they're currently working on or need to work on. Some also opt to use the @author tag to indicate who wrote a certain line or section. It's worth noting, though, that many other devs vehemently oppose the use of such comments, as Git commits are a much more robust and reliable way to indicate who authored what within a given file. Environments and configuration. When it comes to application configuration, Node provides woefully few conventions, if any. When configuring an application to run on localhost, this issue is of trivial importance. But once you've got an application that needs to run in different ways within different environments, on a staging site versus a production site, for example, configuration issues can come into focus. Unfortunately, there's no given solution that works in all cases, because much of the configuration of an app is dependent on the features available within the environment the app will eventually be running in, and the continuous integration and deployment systems that will ship the app to those environments. Here we'll go over a few of the most popular options. The first option, and likely the most popular, is to start your application with the node_env equals environment name, such as node_env equals staging or node_env equals production. The command line variable will become accessible within your Node application at process.env.node_env. Really, any command line argument set will be available at process.env.that variable name, but node_env is a particularly popular convention. You could just as easily call it foobar equals production to the same effect. At any rate, since the environment variable is available within your application, many developers will create a single configuration file with a switch inside of it. This configuration file will export only the variables configured for the environment in question. Any of the other Node files can require that config file, and the variables they'll see will be specific to the environment they're in. This is the convention we'll be using later on in the course, so we'll dive into how this works in detail much more later. Don't worry if you're still a bit confused right now. Another convention that we won't be using, but is still popular, is to pass every single configuration variable to the Node app when it starts. For example, rather than having a config file that states what DB password is in different environments, you would simply pass the DB password to the Node app when you issue the start command. This convention sounds unwieldy and hard to manage, but is actually a fairly elegant solution and has a number of benefits. First, for a large project or an open source project, none of your configuration gets committed to source control. Second, you write your code in a much more functional way, and this makes it much easier to write tests. Third, when your configuration needs to change, you just stop the app and restart it with the other variables. No code changes needed. Another convention is to use a .env file. This is a file whose name is predictably .env and sits in your repo, but gets ignored by source control using a gitignore file. The idea is you put all your configuration inside of the .env file, whose format is similar to YAML, and then your application reads that file. Ideally, your testing and build systems would insert .env files into the codebase before they test and deploy it, and developers would have their own .env files living in the repo for their localhost work. Styles and patterns. Like PHP, Ruby, and Python, Node developers tend to code with certain styles. By far, the most ubiquitous and popular style guide is published by Airbnb and is worth reviewing here. This is a general-purpose JavaScript style guide, but is very popular with Node.js devs in particular. Another influence on style comes from the linters that are popular in Node.js projects, namely JSHint and JSLint. These linters will catch many style issues that aren't of major consequence to the function of the application, but are common conventions used. Rather than going over all the styles and patterns here now, just pay attention to the way applications in this course are written later on. I'll try to adhere to popular patterns whenever possible. Error handling. As you'll see in the coming lectures, our functions and libraries will take a common approach to error handling. This approach has three components. 1. Errorback. This is another convention popularized by Express. With the errorback pattern, every callback's first parameter is an error parameter, which should come back as null, undefined, or false if there's no error. 2. When writing functions, we avoid throwing exceptions most of the time, opting instead to return the encountered error to the caller, such as through the errorback parameter. Since Node.js is single-threaded, thrown exceptions kill the entire application. So if a request comes in to your Node REST API, for example, and you encounter an error and throw an exception, the entire application will die. Not just the process that's handling that particular request, but the entire application handling all requests. If you encounter an error that truly should kill the whole application, it's fine to throw, but these cases are pretty rare. 3. As in browser-based JavaScript, avoid using globals and polluting the global namespace whenever possible. Many Node applications have dozens or even hundreds of dependencies and libraries. If every library added its own global variables and polluted the global namespace, it would be very difficult to avoid collisions when your application is defining variables of its own. So rather than risk collisions, each module or library should scope their variables to its own module and to its own functions, thus avoiding any namespace pollution. You'll see how we accomplish this and other conventions in the coming lectures.